Hello everyone, and welcome to Logic World. Today we're going to be taking a look at 7-segment displays. We'll go over the basics of what a 7-segment display is, how to build one, as well as how to decode 4-bit binary numbers for displays. Finally, we'll go over how to combine the decoders into a single module for displaying any binary number from 0 to 1. Sorry, 0 to 1. From 0 to 9. So a 7-segment display is a device that allows you to display digits as well as some characters using these 7 segments here. As we get the name from. So there's segments A through G. You can see A is this top one. We've got B, C, D, E, F, and G. And using these, we can determine, or we can display different numbers. So if we remove G here, we've got a 0. If we do B and C, we have a 1. If we do A, B, C, D, and G, so A, B, C, D, and G, we have a 3. So following that logic, we can display any number from 0 to 9, as well as some hex characters, so A, B, C, D, E, F. And if you wanted to, you could continue that by adding more, but we're going to go basic here and just worry about 0 through 9 for now. So as you can see, the display does not require any logic inside of the display itself. It's only wires and connections. And we will be building this. So let's go ahead and do that. So to start off with, we're going to use a circuit board. We're going to drop this down and go 9 wide. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we will go some distance out. Doesn't really matter at this moment. And then we're going to go up. So we'll go 7. And I'm shooting for 7 by 12 for now. You can compact it later if you'd like to. We'll build one, and we're going to go ahead and copy this, and we'll just throw it here at the back for now. I'm also going to hit G and hold Control and just move this into the corner here, and that will be that'll help for later on. Not important, but keeps things tidy. So now that we've got our circuit board, we'll go ahead and throw our panel displays on, and it's just going to be 3 per segment. So we'll just go ahead and build out essentially an 8 using these segments here. So there's all of our segments. If I we'll go ahead and take some through pegs and add them here at the bottom, as well as this side. You'll see later on why we're doing that. I'm going to grab the labels that I already made over here because I don't feel like recreating them. I would recommend, at least for your first display or while you're figuring things out, to go ahead and label these. It really helps as you're trying to see which wire goes to which segment for decoding your numbers into decimal. So now that we've got that, we'll go ahead and just hook each one of these segments up, like so. Now that we've got all those hooked up, we want to connect each of the wires. So this is obviously backwards. So on this side, we've got A. On this side, we've got G. Up here, we've got A. And it's going to go, since we're looking at it at the back, it's going to go counterclockwise around, with G being this middle one, A being the top. So I'll just grab some pegs here. Connect a peg between there and there. So that's A. We've got B, like going right here through the middle. B. For C, we can do something like this. You don't have to hook them up exactly the way I am. It doesn't really matter. You just need to hook them up to the correct location. We also have this panel here that we can use, so we will do that for right here. So here I'm going to add one about there-ish. Drag that across, and then we need to go from here right to there. This one as well, not connect to that, thank you. Go up roughly there. There. Let's connect these up. And the final one is right here in the middle, so we can go, can't go there. Might be able to go there to there. Yes. So now that we've got all these hooked up, we can test it. Just drag out this. We can throw down some switches. Go ahead and connect these up. So if I turn on G, nothing happens. So that's really awesome. That's because I didn't connect that. That's why you test things. We'll go F. There's F. E. There's E. D. C. B. And A. So we've got them all hooked up correctly. Let's see if we can turn them off individually as well. There's no wires crossing. What was that? Okay, that did turn on. So there we go. Now we've got our 7-segment display. This is essentially completed. The last thing is connecting these guys to these guys. You'll see it crosses in the middle. That's what we want because this is the other side. We can even take these labels here. Go ahead and place them on this side. And then if we can move the whole thing together, and again, if you put your circuit boards so they line up here in the corner, one nice thing you can do is take another circuit board and go like that and enclose the whole thing. If you hit G and hold Control, you can move them within the square instead of just moving an entire square. We'll do that. So you can add one to the top here. You can remember the controls. So, and we will just grab it and move it into position. And there we go. Now we've got our completed 7-segment display in its own little module here. We can resize this and we can get rid of these. Don't need it anymore. Resize this. There we go. So now that we have a 7-segment display and we know that it's working after testing it with the switches, we want to, we want to be able to take a number that our computer or our logic calculator, whatever we're making, and we want to be able to decode those binary digits into something that our display can handle. So in order to do that, we're going to take a circuit board. And I'm going to go 9 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9 by 9. 3, 4, 5, 6, 7, 8, 9. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8. Not. There we go. Get that. And I'll go ahead and put these pins in. So we're going to be building our decoders. If we go and look at the ones I've already built, you can see they all are almost identical. At least these buffers, these input buffers here, are fast buffers that I'm using as inputs. I have more fast buffers on this side that I'm using as outputs. They are identical all the way across. and that's just going to make it easier later, so we can stack these and combine them in a nice way, like this, where all your lines are running to each one of them, and you don't have a big mess of wires all over the place. So starting with our 9 by 9 square, 4, 5, 6, 7, 8, 9. Okay. Starting with our 9 by 9 square, we'll go ahead and add some fast buffers on this side. These are going to be our inputs. So this is 1, 2, 4, and 8, each bit in a 4-bit binary number. And then our outputs, 1 for each of the segments. And at this point, I would take this and go ahead and copy it. So there's 2. You're going to want 10 of these total. 4. It again. It's 8 and 10. Got all of those. Now we just need to add the logic to each one of these boards to represent a single number for our display. So this first one is going to be 0. So 0, there are no bits connected. So all of our bits on our 4-digit number are off, indicating 0. In the middle here, we're going to want to add an inverter. So this inverter, we're going to connect everything that is not lit up, everything that's not connected, not turned on. So in this case, it's a 0. We have nothing enabled. Everything's off. So all of our lines are going to go into this inverter. And then in order to represent a 0, if we look at our display here, we can see we need A, B, C, D, E, and F. We don't want G. So A, B, C, D, E, F, and that's G. So we're just going to connect up all of the ones except for G. Connect that to our inverter. And now if we connect the output to our display here, we can see we have a 0. Awesome. So if we copy this, go ahead and connect this up to the next one. Here we're going for a 1. So one way to have a constant bit is just have an inverter. So that's on. So we can connect this up to the 1 bit. We can see this turns on. So then we throw our inverter there. We connect everything that's not lit up to our inverter. And now we have 2 red lines here. What we need to do is AND these together. So it's going to be if the 1 bit is turned on and the rest of the bits are not turned on, then to be displaying our number. So if we, then it's representing the number 1. So if we connect that up, move it around so it fits, we can go for a 1 that is B and C right here. So we're going to connect those up, connect that to our and now we have a 1. And we can just keep doing this. So I'll show you a couple more. So we can, again, connect these. We'll go here, we'll add a inverter, and we'll connect number 2. Here we're going to, again, add an inverter, connect everything that's not lit up to our inverter, add an AND, connect the lines that are lit up to the and then we just need a 2. So we've got A, B, G, E, and D. Another way to think of this for 2 is it's lighting up everything except for F and C. So if we go over here, we can say, okay, no F or C. So we've got A and B. We'll skip C. D, E. We'll skip F. And there's, sorry, we will take F. No, we will not. And we'll just hook up each one of those pairs. And now we've got the number 2. And one more, so you can see a little bit of a difference when we start having multiple pins enabled. Again, back these up. Here, inverter. Because this is the number 3, we're going to be connecting both the 1 pin and the 2 pin, which of course added together equals 3. Here we're going to be adding an inverter, like normal, connect everything that's not connected. Now we have 3 red lines, 1 from the inverter and 2 for each one of the pins that we have enabled. And so we're going to look at our AND, hit X, and you can increase the number of pins. So now we've got all 3 of these going into that AND. Of course, for 3, we need A, B, C, D, and G. So A, B, C, D, and G. So if we connect those, we have a 3. So that's pretty much it. Just continue with each one of these numbers. Again, place an inverter, or sorry, place down, place an inverter, connect up the lines that would equal the number you're trying to represent in binary. So for 4, our next number, we would be placing an inverter, connect that up to 4, then place an inverter, connect everything that's not connected, that's not lit up, and then place an AND. If there are more than 2 of these lit up, hit X, increase your count. You may even have to go to count number 4. If you have 4 lines hooked up, or 4 lines that are enabled inside of the chip. And then looking at your display, figure out which segments you need and connect them up. Okay, so now that that is done, at the end you should have 10 modules, each able to represent a single number on your display, 0 through 9. Once you have that, we can start building our decoder, our main decoder here, that's able to take any of the combinations of bits and display them one by one. So if we want 9, we can flip the 8 and 1 bit, and we have a 9. If we want 3, 2 and 1, and we have a 3, and so on. So this allows us to combine all of these together for a single display. So because we built these modularly, they're all the same size, we already have mounting pegs, and all the inputs and outputs are in the exact same location. What we can do is grab these, so I'll just go ahead and copy this, place it down, and then we can grab another one. You want to grab it from this corner, or from a corner that has a peg on it. So you can see you can just look over the peg and it snaps right on it. If you don't do that, let's say I grab it from the middle here, I'm going to be grabbing it from the middle. It's not really possible to put it on the peg. So if you hold Alt, it'll lock in place. You can move your mouse to a corner, let go of Alt, and that will grab it from that location. So then you can slap it on there. So we'll just continue stacking each one of these modules that we've already built until it's till all 10 modules are on. Okay, now that we have our tower, all of our modules stacked on top of each other, we're going to want to connect all of these together. And so we're just gonna grab these, There, you'll see it connects in a line. Gonna go all the way up. Once you have the outputs all hooked up, we're going to do the same thing on the inputs. Now that we've got all the inputs and all the outputs connected, a bus, we can connect up a 7-segment display. So I'll go ahead and throw down a circuit board. We can grab one of our 7-segment displays that we made. Now, because we have these pins on the back, I can rotate this or delete it. I can rotate this so that our display is in front, and we can still connect to the back, which is super useful. So if I'll just build a little circuit board. So panel switches. Eight. Connect these up to our inputs. Then on this side, we just want to connect these over. So we can do like this. These up. And I have a problem. A is not connected. One. There. A is not connected there. Uh-oh. All right. So this is a good test. I don't know why grabbing this broke it. But for some reason, you can see these wires should be crossed from that one to that one to that one to that one. But it broke, so we're going to make it a little bigger. Connect that up. That up. There we go. I have no idea why that happened, but there you go. There. Sure, the other side's messed up, but whatever. So now we should have a working 7-segment display with a working decoder can display any number between 0 and 9. And that's it. Thanks for watching.